All right. Welcome to the first AI/ML Loft event of 2020. My name is Morrison. I am a Principal Solutions Architect focusing in AI/ML. I focus mainly on media accounts, but I focus across the broad portfolio of AI/ML services. So this is the beginning of a multi-day effort to help you understand AI/ML and where it positions itself in the AWS stack. So the goal of AWS is to put machine learning in the hands of all developers. And we'll talk about all the different ways we go about trying to do that. Our intent is to make it easier to build. Easier to build, easier to deploy, easier to run in production, and easier to scale and easier to apply what you're doing in ML to your business. Let's start with, has anyone been to a Loft event about AI/ML before? Is this a first event for most people? Okay. I'm going to talk about the machine learning stack. First, I'm going to show you the stack as it stood last year, which is a lot of different services across a lot of different technology levels, from developer to data scientist. Moving into this year, the ML stack has grown significantly, and I'm going to focus a lot of today on where we've improved, where we've enhanced the service. A lot of the different workshops throughout the week are going to cover different services within this stack. Some of these things are so new that they're in preview, and we may not get to in the short amount of time we have, so that's where I encourage you to keep checking with the Loft. We run these very, very frequently, and the agenda changes throughout the different times we run it. So the stack as it is. We start at the bottom with frameworks and infrastructure, and this is where developers and data scientists, heavy data scientists, will end up working. So this is the frameworks, the actual hardware that does the training, and moving up, we have ML services, which are more data science and developer focused. So that is the end-to-end training workflow. And at the very top, we have AI services. These are API-driven services where you feed it data. Could be an image, could be text, could be view data from an application, a streaming media application, could be financial data for fraud detection. And we will either give you an inference based on a model or train a model on your behalf and give you an inference based on that. So again, bottom of the stack is developer, data scientist. We'll go into each of these a little bit. Unfortunately, we have so many services. In the 30 minutes I have to kick this off, I can't even explain what each service does in due course. So at the bottom, we have our frameworks. So we are framework agnostic. Our goal is to give you whatever tool you need to do your job. So that could be TensorFlow, PyTorch, Chainer, could be one that hasn't come out yet. The AI space moves very quick. It's moving multiple times the speed of Moore's law currently. So our goal is to be able to get you compiled, optimized versions of these frameworks as quick as possible. And you can run them fully managed or run them yourself on EC2 using the GPU-backed instances if needed. So we have optimized TensorFlow to run in AWS. So that's making it more efficient at scaling, running distributed with tools like Horovod. And it is also available in both SageMaker and the deep learning AMIs as well. And the deep learning AMIs is the Amazon Machine Image. That's again at the bottom of the stack, where it is a pre-compiled with the frameworks, with optimized for CUDA drivers and all the things that generally make it hard to build an instance. So the deep learning AMI comes with the frameworks you see here. We also have a deep learning container, which is built for both EKS, so the managed Kubernetes service, and ECS, which is our Elastic Container Service, optimized for TensorFlow and MXNet. So what we'll be talking about a lot over the next 2 days is the difficulty in building, training, and hosting a model. We like to think it goes like this, but in reality it looks more like this, with a lot of work in data prep, a lot of work in training, choosing a model, optimizing that model, and then where a lot of people haven't even focused a lot of time in is actually once you have that model trained, you've got good results, how do you host it for inference? You know, a small application inferring a couple times a second is one thing, but a large-scale application that looks for millions of inferences is a totally different thing. So moving up the stack, that's exactly why we developed SageMaker, which is to take this and make it easier, make it something that you can do in an automated, productionized methodology. So SageMaker is a suite of services that starts at the very left with unlabeled data and then moves all the way through building, training, and hosting a model. It's also worth noting we have third-party models that you can actually just build and implement in SageMaker as well. So if you have a model or if there's a partner that has a model that is beneficial to you, you can actually just one-click deploy it in SageMaker. If you actually are building models, you can actually host and sell your model through the AWS Model Marketplace. Finally, after the model is built, we have SageMaker Neo, which helps in compiling that model for distributing it in multiple locations. So we're going to go through some of the recent updates here that we've launched in the last year. Over the last year, we've had 50 new capabilities launched for SageMaker specifically. As I showed you in the windy line, the machine learning workflow is iterative and it's complex. So the first step is preparing your data, which is collect and prepare training data of all forms. Once you have that training data, you need to choose or build an ML algorithm. So depending on what you're looking to do, be it linear regression classification, any different type of decision trees, you need to choose an algorithm. Then you need to set up and manage those environments for training. Training may or may not go very well depending. You might run into issues. Your data may not be completely ready for the training. You need to train, debug, and tune those models. Then you need to manage the training. So once you have that, you need to deploy the model into production, monitor its accuracy, validate that it's still accurate, and potentially retrain that model to keep up with your incoming data. You also need to scale and manage the production environment for that model. So where SageMaker fits in. We've recently launched a web-based IDE for machine learning. We've added a lot of features on the left. We'll go through many of these one by one, but we have fully managed data processing jobs and data labeling workflows. We'll get into each of these different service enhancements in some detail. So when it comes to the integrated development environment, we launched SageMaker Studio, which helps with collaboration at scale, allowing you to share notebooks. We'll talk about the experiment management, allows you to do automatic model generation. This is the suite that contains a lot of the different service enhancements. So here's what it looks like. It is a single pane of glass that allows you to create and review your models. Oh wait, sorry, wrong slide. I don't have another slide on Studio. So Studio, as you see, the automatic model generation, which is SageMaker Autopilot. Sorry, I had a screenshot of SageMaker Studio. I can pull it up later. But SageMaker Autopilot allows you to create and review specifically right now classification and regression models. So it allows you to automatically choose, and you can specify a performance metric that you're looking for, so the objective here, and allows you to run multiple training jobs, really take your data, process it, and featureize it, and then build a model towards your accuracy requirements. On top of that, the concept of managing your experiments. So we've also launched SageMaker Experiments, which allow you to track your experiments at scale. So you can track your parameters, your metrics, you can organize them, you can visualize the results of those experiments. Helps you to iterate fast through different experiments. These are all live in the console today. Some of these, again, are in preview. So there is preview documentation on how to access it. The next challenge people had is sharing, collaborating when it comes to data science and reproducibility. So This is an area where large, complex, multi-stage pipelines, custom code dependencies, all make it significant work to reproduce an experiment. SageMaker Notebooks allows you to build and collaborate. And again, this is one of the preview services. So it allows you to log in with SSO. They're fully managed and secure. They're very fast to set up. You can spin up your notebooks without necessarily spinning up all the underlying compute resources. It allows you to share notebooks with a single click. And not in the preview yet is the ability to spin up and down the compute resources as needed. So this is collaborative notebooks in SageMaker. Within SageMaker, and this is not a comprehensive list, we have a lot of built-in algorithms. This number is growing constantly, but these are designed to help you build a model for specific use cases, XGBoost, linear learner, image classification. We don't have reinforcement learnings in here, sequence to sequence, like depending. Each of these has been built and optimized, and many of these are also optimized to run distributed. If possible, the algorithms have been built to run on multiple different GPUs when training. So you can effectively train faster at the same cost using many of these algorithms. Next problem people run into is debugging and profiling deep learning is painful. With neural networks, you have many layers, many connections. It's extremely difficult to debug and profile what is the black box of a neural network. So with that, we launched SageMaker Debugger, which allows you to capture the relevant data, debug your models, analyze and debug the data with no code changes, look for errors automatically based on specific rules, take corrective action, and also visually analyze the model that you've built. So again, this is all available from SageMaker Studio. The next challenge is ML requires complex, hard to discover combinations. So again, requires broad knowledge of ML data, algorithms. So this is where, again, unfortunately the slides showed up earlier, but SageMaker Autopilot, which is the ability to automatically create a model and tune that model without necessarily needing to know all of the data science underlying details. So it allows you to provide your data in a specific format. It's bent specifically towards tabular data, so databases and spreadsheet type data. So it allows you to automatically create, again, classification and regression are the current features. It will generate notebooks for your models with the code, and it will also create a leaderboard and provide recommendations and optimization choices for your model that was created. This is actually in SageMaker Studio, and it is available. It's not in preview, so again, been through these slides. So the last problem is, now that you've got your models built, how do you make sure they're continuously accurate and continuously relevant? So the confidence varies based on input data. Not all predictions are equal. Your data changes over time. If you're modeling financial data, all new data, subscriber, user base, all new data that comes in changes the efficacy of the model. So you can't statically train a model. You need to continuously monitor that model and retrain it. One of the areas for confidence reviewing that we launched a service is Amazon Augmented AI. So it allows you to build workflows required for human review of predictions. So is anyone familiar with the phrase human in the loop? So human in the loop is an area of machine learning where ML is augmented or assisted by human activity. We actually started this journey with Amazon SageMaker Ground Truth, which is a labeling service. Again, I'm focusing on the new launches. I believe we'll cover the other Ground Truth at a different point. But it is the ability to pass activities to humans quickly to validate. So what Augmented AI does, it allows you to take a result, and its native integration is recognition, text extract, and SageMaker, but it is an open service with custom capabilities. You can actually write a script to validate any type of response. So if you think about how it works, is you get a result. Let me make sure, see if I have a slide detailing how. So I don't have a slide to detail how, but a result comes in. So we'll say a computer vision result. You get the labels in that image, and you get associated confidence scores with that. Those confidence scores could range from 20% confident to 99% confident. Obviously, all ML is based on confidence scores for predictions. The 99% confidence score is likely pretty accurate. However, the 20% confidence score may not be accurate. So what AI or augmented AI does, it allows you to pass specific sets of rules to human workers. Those workers can be public workforces, such as Amazon Mechanical Turk. So that is the Amazon Mechanical Turk workforce, which is third-party, which is a group of people that work jobs on Mechanical Turk. So you can actually feed that out and say, I will pay X cents per image. And again, it doesn't have to be image, can be text, can be any type of prediction that your model is making. You can pass that to a human workforce to review, and then that data can go back into your training environment, and it can also be used to validate that label, for instance. A2I and human in the loop in general is very important when absolute accuracy is important. If your model is not able to guarantee 100% accuracy, which models are not able to guarantee 100% accuracy, and you need that, you can pass it automatically to a human workforce. The next area is how to model and monitor the models. So this is the capability of monitoring your models over time to detect drift. So that is the ability to look at your data collected from your endpoints, define a monitoring schedule, detect changes against a predefined baseline. You can detect drift or write your own rules for custom analysis. The drift detection is built in, and it'll allow you to see your data statistics in SageMaker Studio. So you can then decide whether to automatically retrain your model based on new incoming data or whatnot. So that's the enhancements in SageMaker. The top of the stack, as I said earlier, is where developers generally focus, especially if they're not building and training models. So the top of the stack is API-driven services that you provide a specific set of data, and it provides that prediction. I'll go left to right really quickly. Recognition is our computer vision API, so it allows you to feed it an image or a video, and it will detect who's in that video, what objects are in that video, anything from content moderation, so looking for potential nudity or violence. It's great for media analysis. It's good for social media. Moving over to our speech services, Poly, which is our text-to-speech. So that uses neural TTS, or neural text-to-speech, to create lifelike audio from text. And we launched, late last year, we launched the capability for different emotive styles of speech. So a new announcement there was a newscaster. So Poly can now read in the cadence of a newscaster. Transcribe is our speech to text. So that is the ability to take what's being said in a clip, audio clip, video clip, and transcribe that down to text. So as I said, you feed it the image, the audio, or the text, and we'll go through each of these, and you get back a response. For transcribe, you get back a JSON of what's being said. For Poly, you get back a WAV file or an audio that can be played in concert with a clip for anything from dubbing or whatnot. And a launch we added for transcribe is we actually launched a medical-specific transcribe feature. So now, similar to what I'll talk about in a sec with comprehend, you can actually use it on medical dictation. Comprehend. That is our neural topic modeling and entity extraction service. So you feed it a body of text, and it will extract entities. They could be custom entities. They could be dates, places. Am I talking about Amazon, the company, or Amazon, the rainforest? Comprehend allows you to feed it bodies of text and extract entities. The one area where you can actually train a model on your behalf is the custom entities and custom classifications. So if you feed it documents, you can actually train a classifier on, which will be trained in your account on your behalf. Amazon Translate is our neural machine translation service, which allows you to take pairs of languages. I believe we're up to 2,490 pairs of languages, or combinations of languages, 58 pairs of languages. Textract is our document analysis service. So that is an ML-based service that will take documents, extract data from those documents, forms. It's not just OCR, so to speak. It will take images, take documents, and it will extract the relevant data from those documents. Kendra is a new announcement, which is an ML natural language search tool that we announced at reInvent that allows you to take a data set, could be static and S3, could be databases, and allows you to do natural language search on that data. Lex is our chatbot service, which allows you to build slot intent-based dialogue chat sessions. So anything from, think of like an Alexa skill to a web chat for ordering or a web interface. Personalization, which is an area near and dear to my heart, is the area of recommendation and personalization, which is a very, very deep area. We actually have a session on it this week, so I won't go too far into it, but we've launched a service based on 20 years of Amazon's experience building and creating recommendation engines. Anything from the videos you see in the homepage of Amazon Video to the order of the art, a lot of different areas for recommendation personalization, search personalization, item similarities. This is a service that will build and train different models for different recommendation engine scenarios. Similarly, we've done the same with forecasting, which is 20 years of Amazon's demand forecasting and forecasting capabilities built into a service where you feed it data based on your time series data, and it can build and train a forecasting model in your account on your behalf. A new launch at reInvent was Amazon Fraud Detector, which is similar but for fraud analysis, anomaly detection, and looking for the possibilities of different areas of fraud. So that is a hosted service where you feed it data and will build and train a model on your behalf. Code Guru, which I think is particularly interesting to the people here, is a static code analysis or a code analysis tool using ML to look for code issues. Finally, we also enhanced Amazon Connect, which is our contact center as a service. We enhanced that with Contact Lens, which is an ML-based contact center analysis tool. As I said, it's a lot in a very small amount of time. Hopefully, you'll be able to get into each of these more throughout the week. A particular cool addition we added to recognition at reInvent is the ability to do custom labels. If anyone has worked with recognition, we will work with recognition at the end of the day today. It allows you to detect labels. But working with a lot of media customers, every time someone wants X label, recognition has thousands and thousands and thousands of labels, but it does not have every label that our customers want, and we know that. So what we've added is we've added the ability to add custom labels, where you can actually upload images and use A to I or use ground truth to label those images, or have them labeled yourself, either or, and it will train recognition to recognize your custom labels now. So logo detection is a common use case. We're actually going to do logo detection later today, not with custom labels, but with SageMaker. Custom labels will make this even easier. So you can upload a handful of images of the label you're looking for, train a model in recognition on your behalf, and then evaluate if it's functional, if it's detecting what you're looking for. Here you'll see recognition, for instance, gives you plant, corn, food, vegetable. These are the recognition labels, but maybe you need to know whether it's sweet corn or field corn. That's a custom label job. So anywhere you need to really specify and really get deep into your individual use case, custom labels is a new option to help there. So Kendra, we talked about at a high level, but that is the natural language search engine. So it allows you, again, frequently what people end up doing when it comes to searches is anyone who has an internal search tool at a company has learned the weird code words they need to type to get the thing they're looking for. The goal of Kendra is to eliminate that, is to let people search in natural language. It's to let people say, where is the bathroom on the 6th floor? Not bathroom building type this and that type of thing. So it allows you to use natural language. It's ML optimized indexing, simple API. It is in the console today to get in there and start playing with. Fraud detector, as I talked about, these are a bit deep on the actual services. Allows you to automatically create custom fraud detection models. And it is, again, based on our own experience. It is integrated with SageMaker and allows you to review your detection logic. So with that, we also have over 400 courses to help people learn machine learning. So today is one of the areas, but we have a lot of online information as well. So Machine Learning University, it's the same data that we use internally to train our developers on ML. So here's a link to it. These slides will be made available to you, so feel free to sign up. And I believe that is it for, we have about a minute for questions. I threw a lot at you in a very short amount of time, so let me know. Next we have Deep Racer workshop, so which unfortunately or fortunately for you is me again. So, any questions? Anything you guys want to focus on or have interest in today?
Question, just to clarify,
Yep.
you explained about the comprehend, right?
Yep.
This is also for medical specific?
Comprehend medical is a medical specific iteration of comprehend. So there's comprehend, and then there's comprehend medical, which is designed for medical scenarios.
Like in any specific medical scenario?
I wouldn't say any specific, but like for instance, it's aware of things like dosages and is looking for things. It's aware of medical terminology. And one other thing about all of the higher level APIs that is worth noting, it's very easy to go into the console and just throw a piece of data in and analyze it. So if you want to kind of get a feel for how it works, the design is really done to be API driven, but each of the higher level services has a really decent UI that you can throw a piece of text in and then see what the results would be in a human readable and in the JSON form as well. So,
Just one more
question.
I mean, maybe we'll have discussion in detail. So for the autopilot, do we have any non-linear classifier or linear classifier?
I have to check. I don't know if autopilot, let me get back to you on the break on if, and the question was, does autopilot handle nonlinear classifiers? And Chris, maybe if you could take a look while we're doing it. I'll work to get an answer as soon as possible. I know it's currently, there's about 4, I need to look at the different models it will train on your behalf.
2 questions. The first one is on the transcribe. Does it render into like map all the way to like the coding level, like ICD or like standard format of the medical record?
The transcribe comes back in a JSON format, and it.
Can you repeat?
Yep. Oh yeah. So the question is, transcribe. What format does it come back in? Transcribe medical specifically is what you're asking about, correct? Or.
Standard format.
Yeah, transcribe. It comes back in a JSON format, and I don't know if transcribe medical has this, but there is a real-time component as well to transcribe, which allows you to transcribe in real time and get results back in real time as you're talking. We'll show that later today.
And the second question is on the recognition. Does it estimate the quantity too?
Does it
Estimate the quantity on the recognition?
estimate the quantity of
Labeling the object. Right.
estimate the quantity? Could you do the question? Yeah.
For example, right? There are 4 quantities there.
Yeah. Okay. You would actually calculate that based on the object detection of 4 corn, because you would get potentially bounding boxes for some of the labels. So you'd be able to say there's 4 different areas in the picture where, and the question is, does it estimate the quantity? The answer is it could, depending, especially if we're giving you bounding boxes. Not all of the labels that recognition provides give bounding boxes, and bounding boxes are the XY coordinates. But if there are bounding boxes, you could tell how many of each item there are, for instance. You could also move to SageMaker, which would allow you to build specific models to do things like counting. I know crowd counting is a very common use case that people use. With that, we need to transition over to the Deep Racer workshop. I will be here throughout the Deep Racer workshop and also throughout the day to answer any questions. And we have Chris and other presenters as well. So thank you, guys.